So when we say that kumquats are scarce, we mean what? So scarcity means there's not enough to go around all the time for everyone. It's the unlimited wants and limited resources. So the first option says they can only be grown in Florida. And while they may grow in Florida, and even if it is the only place they can grow, that's not what causes scarcity. B says there are only a fixed number of kumquats in existence, and that's not true. You could plant some more plants and you'd have more eventually. C says something must be given up if one wishes to consume a kumquat. That indeed is true. Because of scarcity, these opportunity costs exist. You must sacrifice something. D says if one wishes to consume a kumquat, one must discriminate against some other goods. That in general is going to be true as well. If you choose to buy a kumquat with a given dollar, you can't then also buy an orange with that very same amount of money. So both C and D is correct. Suppose there are 3 ways you can spend your time from 12 to 12:50 in order of most valued to least. It's key. First, class. Second, sleeping. And third, watching reruns. So this means econ is your highest valued, sleeping is the second, and watching reruns is the lowest. Which of the following are true? A says the cost of going to economics class is the value of the time that you spend sleeping. So if you don't go to economics class, you do indeed sleep. So that must mean that your opportunity cost of class is sleep. So A is true. B says if economics is canceled, then the cost of sleeping is thereby reduced. That is indeed true as well, because if you cancel class, then that means your opportunity cost of sleeping is no longer missing class, but is now watching reruns, something that is lower valued. So B is true as well. C says if your TV breaks so that you cannot watch reruns, the cost of economics is reduced. Again, since the opportunity cost of going to economics class is sleeping, not sleeping and TV, if TV is taken out of the mix, it doesn't impact anything because it was not your opportunity cost. And so that means A and B are correct. When we say that Australia has a comparative advantage in producing Aussies, we mean what about Australia? So remember, comparative advantage is the low-cost producer. You can produce Aussies cheaper than other goods. A says they can produce more Aussies than kangaroos, the only other commodity produced there. And this doesn't mean they can produce more or less. It just means that comparative advantage means they can produce it cheaper. So we don't know for sure that they produce more or not. B is the low-cost producer of Aussies. That's the definition of comparative advantage, so that's true. C can produce more Aussies than any other nation. That would be an absolute advantage. We don't know that they also have one in it, so that's not true. And D can produce nothing but Aussies. Again, they probably can produce other things. It might be true, but it's not for sure true. So that is not it either. And so E can't be correct, so just B is our answer. This question says, when we use the term gains from trade, we're referring to the fact that A, what one person loses, the other one gains. That's not true. In the example we used in class of gains from trade between me and my husband doing cleaning and cooking, neither one of us lost in that scenario. We both were winners, and so we both gain. So that's not it. B, trade merely rearranges good. It may rearrange who produces what, but it's not just a rearrangement. C, sellers gain more from trade than buyers do. That is not going to be true because the gains go to both people. D says voluntary exchange raises our wealth, and that is going to be our answer. Because anytime we can choose to trade, You would only choose to do it if it made you better off, and therefore wealth is higher. This question comes from one of the chapters in reading the Public Issues book, and it says, if the Food and Drug Administration pursued an efficient method of regulating new drugs, it should do what? So efficiency, just like we discussed in class, means the costs cannot outweigh the benefits. And so they must be seeking to maximize net benefits. So let's look at A. Trade-off of the health and safety of some consumers against the health and safety of other consumers. They are looking at that trade-off, right? You don't want a drug to pass too soon or too late. Too soon meaning there's a lot of large side effects and it causes problems or death, and too late meaning people die when they could have been saved by the drugs or have some other conditions. So A is going to be true. B, take into account the relevant costs and benefits when making their decisions. That is also true. If they're going to make an efficient decision, they need to look at all possible costs and benefits. C, seek to maximize net benefits. Again, they're going to be efficient. They've got to be maximizing net benefits. D, seek to equate the marginal benefit and the marginal cost. That's how you maximize net benefits. So D is true as well. So question E is going to be our correct answer. This question is also from the reading, and it says, because government policies always have unintended consequences, we can conclude what? So in this chapter they talk about how certain actions taken by the government have some type of consequences that are not initially estimated. And so since there's extra costs, they might be messing it up. And so here, because of that, A says the total costs of the government generally exceed their total benefits. The total costs are higher, but nothing says it exceeds the total benefits, so that's not true. B, the net benefits often turn out to be less than anticipated, and that is going to be true, because if your costs are higher than you think they're going to be, that means your net benefits will turn out to be lower than you thought they were going to be. So B is true. C, the total costs of the governments are always less than their total benefits. Again, that may be true sometimes, but not necessarily always. D, the marginal costs of government policies are always greater than the marginal benefits. Again, it's not an always greater. Sometimes it might be greater. They're always underestimated, but that doesn't mean to the point to where you should never take the action, which is what D is implying. And so all of them are clearly not correct. And so our answer here is B. Also from the reading, this question states the economically efficient level of safety occurs when. So economic efficiency says that the marginal costs and benefits must be equated and therefore net benefits maximized. So type 2 errors and type 1 errors are not what determine economic efficiency. It is indeed, as C says, where the marginal cost of safety equals the marginal benefit. D says the same thing, but with the total benefits and costs are not what we look for. We look on the margin. And then E says there are no fatalities. And as dismal as it may sound to say, that is not what determines economic efficiency, because it is possible that it is too costly to prevent all possible ones, because you would have to start allowing a lot of things like no one can drive a car or large amount of police. Might have to eliminate flying altogether if you were concerned about that kind of safety. And there's just, the cost is just extremely high, and so it may be so high that it's actually impossible to do. And so the fact that there are no fatalities is not what's required for economic efficiency. It's just that the marginal costs and benefits equate. Here we have a table showing the total benefit and total cost, and we need to fill in our missing columns and then answer some questions. So the marginal benefit is the change in total benefits. And so we need to look when we add 1 day to our trip to see, or 1 more trip to our semester, excuse me, we need to see how much the total benefits change. So when we go from no trips to 1, our benefits go from 0 to 65, which is a change of 65. When we go from 1 trip to 2 trips, we go from 65 to 120, which is a change of 55. When we go from 120 to 160, that is a change of 40. 160 to 190, that is a change of 30. And then 190 to 205, that is a change of 15. And remember, when you draw the marginal benefit curve, it's downward sloping, and these numbers are indeed decreasing. So that means it's a good sign that we might have done them right. Marginal cost, similarly, is the change in total cost. And so we want to see when we add another trip what happens to our total costs. So when we go from no trip to 1 trip, our costs go up by 5. 1 trip to 2 trip, our costs go up by 10. 2 to 3, it's an increase of 15. 3 to 4 is an increase of 20. 4 to 5 is an increase of 25. And then our last column is our net benefits, which is the difference between all of our benefits and all of our costs. So for the first one, we have 0 minus 0, which is 0. For the next one, we have 65 minus 5, which is 60. For the second one, we have 120 minus 15, which is 105. For the third trip, we have 160 minus 30, which is 130. The fourth trip is 190 minus 50, which is 140. And the last trip, 205 minus 75, which is 130. And so we looked at the marginal benefits and we saw they were going down. We draw a marginal cost curve sloping upward, and we see that indeed these marginal costs are going up as you add more trips. And the net benefits usually increase and hit some type of a maximum and turn around, and we see that happens here. Okay. So that's a good sign that all of our numbers are correct. So let's keep going. Question 9, how many trips home should you make? And what is the payoff for making that choice? So all of these decisions, we're looking for where marginal benefit equals marginal cost if possible. If we can't get there, we want to get as close as we can without having marginal costs be higher. So let's look at what we've got. For 1 trip, we have marginal benefit being 65 and cost being 5. That means you pay $5 for something worth 65. That's definitely a good deal, so you should at least take 1 trip home. Your second trip costs you $10 and benefits you 55. So that trip is also a good one to take. The third trip costs you 15 and benefits you 40. So also a good trip. The fourth trip costs you 20 and benefits you 30. So again, a good trip. And then the last one costs you 25 and benefits you 15. So now you're at a place where it's more costly than it is beneficial, and so you did not want to do that. So you go back up and we see that 4 days and net benefit of 140 is where you want to stop. So 4 trips, and that has a net benefit of $140. So that answers both of our questions. Number 10 says, suppose you realize that you left some things at home, making the marginal benefit for each trip rise by $10. How many trips should you take now? So that means the 65 is now 75 this marginal benefit goes up, this marginal benefit, this one, and this one. So now the ones that were worth it before, of course, are still worth it, but let's look back at the fifth one. Now we're at a place where 25 is what it costs and 25 is what it's worth. So it's no longer less than, it's actually equal to. So now you want to take 5 trips. So in this section, we're going to be drawing some graphs and seeing how the shifts in our curves impact our decisions. So in these set of scenarios, we're deciding about how much time to spend at the lake. So question 11 says, weather conditions in September are such that the marginal benefits are higher, or benefits of being at the lake for any given amount of time are higher for you in September than in August. So the marginal benefits are higher in September than in August. So the benefits have gone up that month. And so what's true about each of the following? So let's sketch a graph. And here we have the amount of time at the lake, and here the value of the lake. So we're going to start out with August because it's our first month. So here's our marginal benefits of going in August, our marginal cost of going in August. And so where they intersect gives us the amount of time you'd spend in August as well as the marginal benefits and costs for August. Okay. Now it's September and it tells us the marginal benefits are higher in September. So we have an outward shift, an upward, of marginal benefits. So this is marginal benefits in September. So our new intersection here gives us the amount of time we'll spend in September and the marginal cost of September, which is equal to the benefit in the last hour. So looking at our questions, the first one says the amount of time spent at the lake. So that's this quantity down here. And we see because the marginal benefits are higher, we're going to spend more time at the lake in September than we did the previous month. For net benefits, that is this triangle here. So originally, these are the net benefits, the difference between the marginal benefit and the marginal cost. But now, we're going here. And so our new net benefit triangle is bigger than our original, so that is higher as well. The total cost is the area under the marginal cost, and so our original total cost is this. But now that we're going longer, or spending longer at the lake, our total cost goes up to here. So we see our total costs rise as well. Now we have a completely new scenario for going, and it says that weather conditions in November are such that the marginal costs of going to the lake are higher than in October. So November has marginal costs that are higher. So what is true about the following? So we're going to again start out with our graphing for October, with our amount we spend here and the dollars for going. So the marginal benefit of October and the marginal cost of October, our quantity in October, and our marginal benefit and cost of the last hour we were there. Okay, and it says in November the marginal costs are higher. So that means for the same amount of time, it's going to cost more. So our marginal cost has to shift up like this for November. So this is our new intersection, and we end up with this being our equilibrium. Okay. And so the amount of time spent at the lake has gone down in November relative to October because it's more costly for each amount of time you're there. The net benefits started here. Again, it's the difference between the marginal benefit and the marginal cost. But now the net benefits are only going to here because we're not spending as much time. So the net benefits fall as well. And then the total benefits are the area under the marginal benefit curve. So it's this green area originally, but now we're only going to there. And so our total benefits are lower as well. So in this question, we're going to compare May to April. And since school is out in May, the marginal costs of being at the lake is lower in May because you don't have those schoolwork to do, so your opportunity cost is going to be a lot lower in May. Also, we're going to assume that the marginal benefits of being at the lake are higher, and that's because the weather is warmer, and therefore the lake, in May than in April. So let's go to a graph. So we draw our starting axis, and we get the marginal benefits in April and the marginal costs in April. And we have an equilibrium amount we go, and the marginal cost and benefit of the last hour spent at the lake. So there's our starting graph. In this one we have that the marginal benefits are going to be higher in May, and they're higher because it's warmer, that's right. And then the marginal costs are lower because you don't have schoolwork. So this is our new equilibrium. Both of the curves have shifted, and so anytime both curves shift, there's something that's going to be unknown, so we need to pay attention. When looking at the amount of time at the lake, we can tell for certain that that's gone up in May because higher marginal benefits would make you go more and lower marginal costs would make you go more. So we can tell for certain this has gone up. So the amount of time at the lake is higher. The net benefits from being at the lake is the area between the two curves. So the original amount is that red triangle. The new amount follows the new marginal cost and benefit curves and is this bigger red triangle. So the net benefits have gone up as well. The total benefits are the area under the marginal benefit curve. So starting out, these would be our total benefits. But now our total benefits goes up to our new curve. So it's this bigger trapezoid. So our total benefits go up as well. So in this case, we did actually know everything because of what was asked. But if it had asked about what was going on over on this axis with the marginal cost or benefit of the last hour, we wouldn't have known that. So we couldn't have determined what happened. So in this question, we have Bobby and Jane, and they can fish or sew. We have that Bobby can catch 5 fish and sew nothing, or sew 10 items and catch nothing. Jane can catch 6 fish or can sew 2 items. So those are Jane's options. So we're going to graph them on our axis, and it says we need to put fish on the horizontal. So fish are down here and sewing is up here. Okay. All right. So we've got for Bobby 5 fish, which is here, or 10 clothing, which is there. So this is Bobby. We'll switch to green for Jane. So we'll make a note of that, change her color a little bit. Okay, and so Jane has 6 fish, which is just right here, and 2 sewed clothes right here. And so there gives Jane's production possibilities curve. Okay. So to calculate Bobby's opportunity cost of fishing, it's the measured in what he's giving up, and what he gives up when he fish is some sewed clothes. Specifically, he gives up 10 sewed items for 5 fish. And again, that was measured in the items he sews. So that reduces to 2 sewed clothing. And if we look at the opportunity cost of sewing, that's measured in the number of fish you'd give up per sewed item. And again, it's measured in fish. And so that comes up to 1/2 a fish. So that means if Bobby is going to fish or catch one more fish, he makes 2 less clothing items. Or if he makes 1 more clothing item, he gives up on 1/2 of a fish. Switching to Jane, her opportunity cost of fishing is the amount of sewed clothes per fish given up. So she could make 2 clothing garments and 6 fish, and it's measured in sewed clothes. So the opportunity cost of 1 more fish is 1/3 of a sewed item. Whereas for sewing, her opportunity cost is measured in the number of fish per sewed clothes. So that's 6 over 2 fish. And so that comes to 3 fish. So if Jane is going to catch 1 more fish, she gives up on 1/3 of a sewed clothes, or if she's going to sew 1 more garment, she gives up on 3 fish. So to determine comparative advantages, we need to look at the opportunity cost. So the opportunity cost for fish, we're either giving up on 2 sewed clothes or 1/3. We'd much rather lose 1/3, and so that means Jane can make fish more cheaply. Then looking at the opportunity cost of sewing, we have 1/2 of a fish or 3 fish. 1/2 of a fish is a lower cost, and so sewing is cheaper for Bobby to do in terms of opportunity cost. So that means Jane must have a comparative advantage in fish because she gives up fewer sewed clothes to fish. And Bobby must have a comparative advantage in sewing because he gives up fewer fish when he goes to sew. Absolute advantages are looking at the maximum amount. And so when looking at fish, we have 5 from Bobby and 6 from Jane. And since Jane can do more, that means she has an absolute advantage in fish. And then looking at sewed items, Bobby can do 10 and Jane can do 2. So Bobby has an absolute advantage in sewing. Okay. Right, so the first person to fish is the one with the comparative advantage in fishing, which is Jane. And the first person to sew is the one with the comparative advantage in sewing, which is Bobby. In order to get their joint production possibilities curve, first we need to find out their endpoints. So we know that looking on the fishing axis, Bobby can catch 5 fish, and Jane can catch 6. So that means together they could catch 11, just about there. And looking on the sewing axis, Jane can make at most 2 garments and Bobby can make 10, so together they could make 12, which is about here. Okay. So now we need to figure out which curve we're going to start with first. So to do that, we'll start up here at the 12 sewed clothes. So if they're both sewing, they'd have 12 garments. But then if they decide they want to add 1 fish and send someone away from sewing, the person that should do that is the one that has the comparative advantage. And earlier we said that was Jane, and we also said Jane had should be the first one we sent. And so her curve goes from 2 until 6, and therefore we need to go down 2, which would be at 10, and we need to go over to 6. So this point here of 6 10 would be where we'd switch, because Jane's curve looks like that. It goes down 2 and over over 6. And then Bobby's would be the one to finish it out, to go from there to 11. And so their joint curve would look like this. All right, so using the information we already have, we know that the price of fish is equal to the price of sewed clothes. And our goal is to maximize their combined income. And so we can choose any price as long as it's the same. And so I'm going to make fish $1 and clothes $1. So let's look at our options on our graph. The first one is 11 fish and no sewed clothes. So it's this point down here. So that's a possibility. The next is no fish and 12 sewed clothes, which is up here. So that's also a possibility. The next is 6 fish and 10 sewed clothes. Oops, I made an error on the previous one. That should be 10. And so this point. So that's also an option. The next one is 11 fish and 12 sewed clothes, which would be up from 11 and out about here. So we can't do that. So that's not an option. And then we have 5 fish and 2 sewed clothes, which would be about right here. So it's inside our production set, but we could get more fish or sewed clothes without having to give up any of the other. So that's not going to turn out to be the best option either. So our question is, between these 3 points, which one is going to be the best? Okay, so we have 11 fish at $1 a piece, means $11. 12 sewed clothes at $1 a piece means $12. 6 fish is $6, and 10 items of clothes are $10, and so that's a total of 16. So our highest possible point here is going to be C. In this question, we have that Jane now gets a sewing machine, and so her ability to produce fish is the same, but she can make more sewed clothes. Also, she doesn't share the sewing machine with Bobby, and so he's not changing. So originally we had calculated Bobby's opportunity cost to be those numbers and Jane's to be these. But now that she has the sewing machine, hers are going to change. Her new production possibilities and opportunity cost looks like this. So her opportunity cost of fish, again, are the amount of sewed clothes she gives up, which is now 8, still for the 6 fish. And so that reduces to 4/3 of a sewed cloth. And our opportunity cost of sewing is now the number of fish per cloth. And so we have 3/4 of a fish. So now to compare, we need to look at her opportunity cost of fish versus his. So she gives up 4/3 of a sewed clothes, and he gives up 2 sewed clothes to fish. And so she still, 1 1/3 is less than 2. So she has a comparative advantage in fish. And then when looking at sewed clothes, we have 3/4 compared to 1/2. And so 1/2 is still lower, and so he maintains his comparative advantage. So this means even though she has a sewing machine, she still does not have a comparative advantage. So that means she does not have one in sewing yet. She still has it in fish. So B is not true. And neither is C, because Bobby still has his in sewing. And so it is true that they are left unchanged, but it's also true that Jane's wealth is now much higher than before. In fact, their joint PPC is higher than before, so their joint wealth is likely to be higher as well. But we know for sure hers is. And so that gives us E, both A and D. D.